So, yeah, how many people here, show of hands, have spent time doing benchmarking in their careers? Okay, and how many of those people, specifically with Ceph? Cool. Okay, most of the room. And how many people loved every minute of it? Three? Three. Mark Nelson. Two others. Okay. Okay. Interesting. So I think benchmarking can be painful for a few reasons. Firstly, you need to run tests many times and consistently. The tests you need to run need to be a minimum length of time. There's loads of variables, loads and loads of variables, and so you try and change one variable at a time. But then you deduce results and realize that even though you were only changing one variable, there was actually loads of variables at play, and what you thought was true was not true, and you just give up. So it's kind of painful because you want good tools, and you don't always have. Sometimes your tools get in the way. So for Ceph, benchmarking is even more complicated. First of all, we have many interfaces. So we don't just interact with Ceph one way, we do it many ways: block, file, object. We have massively varying workloads. So for each one of these protocols, they all have different characteristics. So we need to take differing approaches and measure them independently. Distributed systems need distributed benchmarks. So we need a benchmarking tooling that's going to scale with our distributed system, right? Also, and this is a big one, workloads can be invisible to operators because most people that are deploying and operating Ceph aren't actually using it themselves. They're presenting it to a set of customers, and those customers are using it in whatever way. Who knows? Please don't do that. And so sometimes, basically predicting the workloads that you need to optimize for can be a challenge if you don't know what those are. And finally, this is great as well, is that Ceph's background work can also get in the way. So Ceph does a whole bunch of background work that's semi-visible or sometimes invisible, and this can have a performance impact if you're not aware of it. So you need to kind of be aware. So up until now, there's a whole bunch of different tools for benchmarking Ceph, but a big one for a while was Cosbench. And maybe some people, how many people are still using Cosbench today or have used Cosbench in the past? Wait, okay, so start with have used in the past and you're still using today. Two people, kind of, one and a half. Okay. We used Cosbench for a while as well, and so did our customers. And we thought, oh yeah, Cosbench, great, yeah. But actually, Cosbench had a bunch of issues. The first one is that the Java native interface is pretty expensive, and so if you're doing it for anything other than S3, it's not great. Amazon has a pure Java implementation of S3 clients, so it's cheap to run S3 benchmarks from JVM, but for anything else like Librados, LibRBD, Cosbench has to traverse the JNI, which is expensive. Also, Cosbench is unmaintained. It's been unmaintained for a while, but you could theoretically maintain it. We could pick it up and kind of work on it. But the problem is the fundamental architecture of the project is quite painful. It uses this thing called OSGI, and the idea with OSGI is that everything is an independent bundle rather than a monolithic application. So Cosbench was originally targeting lots of different object protocols, and that's probably why they did that. But the result is it's incredibly fragile structure that's difficult to navigate and even more difficult to debug when things go wrong. Then the workflow is also very manual. You submit these XML jobs and then you pick them up, and there's no build or install system, so the binaries are in a repo, and then you kind of just have to. There's no way. It doesn't really tell you how to build it from source, there's no real way to install it. So basically, in spite of all these issues, lots of people were using Cosbench, and there was a value to that because it was a benchmark in the sense of everyone's using the same thing. So even if it's a bit not so good, everyone's having the bit not so good experience. So there's value in that, right? And so that's why we kind of tried to stick with it. And so we did a whole bunch of work trying to make this more pleasant. We got it building with Maven. We did a bunch of automation to make the XML jobs easy to submit. But eventually the effort here was no longer worth the benefit. So it just made more sense to write our own tool. And that's a diplomatic way of me saying that my colleague Harry just got too irritated with Cosbench and then vanished for a bit. And then he resurfaced weeks later with a prototype replacement. So that's kind of where we're at. So what are the goals of Sibench? We want a tool that's simple and lightweight, easy to read, easy to run, easy to debug. We want it to be linearly scalable, like Ceph is. So we don't want the benchmarking tool to get in the way or to be to benchmark the tool itself. We want to benchmark Ceph. We want to benchmark all the Ceph protocols. We want something that's designed for Ceph. We want it to be low level, efficient, and inexpensive to call C libraries. So we don't want performance implications. So ideally, and this was a core goal, is that each Sibench worker thread matches FIO in performance. And finally, we'd like a framework that gives us some control over the data we use to run the benchmarks as well. So those are the goals. So what did we do? So Sibench written in Go, so it's almost free to call out to Ceph's libraries. It's both a daemon and a CLI tool. So when you install it, the Sibench driver daemon listens for work on a port. And you can then use the CLI tool to generate work for the daemons with localhost as default daemon, but then you can just provide it other workers as well. It handles all the authentication, so you give it the Ceph keys or the S3 keys for S3 and the bucket. And then it does the rest, talks to the monitors or the gateways as needed. It's multi-threaded. So by default, each Sibench driver will spin up on one thread per CPU core. You can actually control that. It's configurable, but most of the time it's about right. It does bits or bytes because networking people like bits and then storage people like bytes, and then they have arguments about which is the right thing to format. So we just do both. And then it has ramp time like Cosbench does as well. So you can say, don't actually record the first X seconds or the last X seconds, so you try and get a representative result. And then finally, it focuses on actual benchmarking and not orchestration, because there's an orchestration piece. So with Sibench, the goal is to run one workload with the workers and the threads and the drivers, not to do loads of benchmarks, but we need to do loads of benchmarks, so that we've separated those two tasks. So here we can see, I actually can't see on my, so here you can see that the different protocols that we support with Sibench to start with. So you can see Sibench talks directly to the monitor pool, and then each worker, you have a worker basically for Librados. You give it a Ceph pool, you give it a Ceph key, you give it a monitor address, and then that's really all it needs. Same with librd, Ceph pool, Ceph key, monitor address, and then each worker thread will spin up an image and read and write to it. CephFS, we don't need to provide a pool, so we just provide a key and a monitor address, and then it mounts the file system, and then each worker thread reads and writes its own files into that directory. Rados Gateway works differently, so you provide an S3 access secret key and an S3 bucket, and then this actually doesn't even need to be a Rados Gateway. It could be any HTTP endpoint, so you could put your load balancers, benchmark your load balancers, you could benchmark a non-S3 endpoint as well, theoretically. I mean, I guess that would work. I think you can. And then finally, you have the ability to benchmark native, block, and file as well. So you can just point it at a block device or at a folder, and you'll have to mount or map these manually, but you can then use it to benchmark things like iSCSI or NFS and SMB as well. So some of the other cool things that Sibench can currently do. It can do bandwidth limiting. So we have customers that give us requirements such as, hey, we need to have 100 milliseconds of response time when doing 30 gigabytes of traffic or whatever. I just made those numbers up. But it's a good way of getting latency numbers at a certain bandwidth. So you can say, I don't want to max out the bandwidth on every driver. I want to hit a certain bandwidth limit. And then after that, what I'd like to do is kind of optimize for latency. So that's pretty good. It's a good way to make sure the workers aren't maxing out their pipe every time. It has this slice generator, so by default, if you don't use this, it generates random data. But if you want to measure for compression or deduplication, you can't do that with random data. So this actually generates a bunch of random data into an array, a buffer, and then it provides slices of that buffer so that it can kind of reuse the same data. It does read-write mixes. So you can, by default, it just does reads and then it does writes. But then if you give it a read-write mix, you can specify a blend of reads and writes to conduct in parallel. So like 50 reads, 50 writes, or 30/70 or whatever. And then it also has support for writing out all the individual stats from each worker. So this can be used for trying to understand what's happening if the numbers don't make sense, or you just want to debug exactly what happened in a workload. Or if you want to run statistical analysis over the data. Obviously the file is huge because you're getting a JSON file of like every single thing that every driver has done, every thread, so that's quite big. And then also, by default, Sibench doesn't clean up after itself because of how deletes work in Ceph. So you can actually ask it to delete or not, and see what the difference is going to be in performance. So what's Benchmaster? So Benchmaster is a little Python tool that is a wrapper for both Cosbench and Sibench, and it's for running a series of benchmarks rather than just a single one. And it allows us to provide a set of options to sweep over. So I can say, run a workload for 1K, 4K, and 16K, and it'll go and do all three of those. And it also writes out all the workload results to Google Sheets. So if you can spin up a Google Sheet, and I'll show you that in a second, which is quite useful. So yeah, it's orchestrator, run a series of benchmarks, and sweep over various variables such as object size count. Yeah. Okay, so what I wanted to do is see if I can get I figured that on this screen, wait, where was it? I've lost my SH session, hold on. That was right. Here we go. Cool. I figured if I have tmux on both screens, then I can actually see what I'm doing, and you can see what I'm doing. Cool. Okay. So so first of all, I want to show you is the fact that it's both a command line tool and a daemon. So it's running as a daemon on this server. For this, I'm just using a cluster we had in the lab, which was like health error for weeks before this weekend, and I had to like go in and try and fix it to use the demo. So I don't know what results I'm going to get, but I just want to show you kind of functionally how this works rather than any performance figures or anything like that. So that's the daemon, and then if I do Sibench sh, you can see that I have a kind of little command line utility for running S3, Librados, CephFS, RBD, block, file, and a bunch of options. We've also got a man page, which I'm a huge fan of. I like man pages. So kind of goes in and gives you some info on various things. And the other thing we have is so wait, let me show you what it looks like to run a benchmark. So here I'm telling it to use bytes. The uptime, so the ramp up is 1 second, the ramp down is 1 second, the runtime of the benchmark is 5 seconds. I give it the Ceph key, and I give it the monitor as a target. So this is just a Librados benchmark. So you can see it's telling me the list of drivers, which in this case is just the local host node that I'm on. And if I had more nodes, I'd pass them as on the command line as the workers. And I can see the object failures, verification failures, it's all fine. I can see the write and the read, and they're kind of separated.
Can you zoom in?
Can I zoom it? Oh yeah. Let me see. Oh yeah, sorry about that. So let me just scroll up. So you can see this is the command that I ran. You can see it's creating a JSON report, writes, and then there's a prepare phase and a read phase. And at the end, it tells me, hey, here's the kind of results, and it breaks it out for per target and per driver as well. Obviously with Rados, you're only going to have one monitor anyways. It doesn't really matter. So for RBD, this is going to look very similar. Basically, it's exactly the same command, except I'm using RBD instead. And what you see here is the same thing, but what's happening is it's actually creating loads of RBD images from each worker thread. So in this case, I only have one thread, one driver, but I have 32 cores on this node, so it's going to spin up 32 RBD images, write and read to them. But that's all configurable, so it's just defaults. So same thing. So the next I want to show you is the Benchmaster thing. So I'm going to create a new sheet, and I'm going to call it, I can find my cursor, here it is, Ceph Days NYC. So I'm going to create a spreadsheet, and it's going to share it with me. So you can just generate some Google API credentials and pass it to the tool, and it'll just talk to Google Sheets, and this all falls within like free API for Google Sheets, so it's fairly, you have to pay for it. So then it's just shared this sheet with me. I'm going to go back to the terminal. Right, so this time I'm not going to run a Sibench command, I'm going to run a Benchmaster command. Well, bench is also shared by Sibench, so my reverse, okay, there we go. So this is a Rados benchmark run with Benchmaster. I'm going to tell it which sheet. Specify the pool, same again, runtime, up, down, and then here I'm going to give it a couple of sizes. I'm going to say 64K and 1 meg, and I'm also going to give it a couple of read-write mixes. So first 0, so basically just default, which is no mix, and the second one is a 50-50 mix, and I'm going to call it initial test, and again the target is the monitor. This tool is a lot more verbose than Sibench. For S3 as well, you provide the list of targets. So if you don't have load balancers, you can still test a S3 across a whole number of endpoints. But you don't need to do that with Rados. And I haven't set up Rados Gateway, so I won't show you this today.
Danny, while that's running, can we get the report results in a machine parsable format, like JSON, YAML?
Yep. Yeah, it outputs to JSON by default. So it'll drop it somewhere. I think you can tell it where to drop it as well.
Only with Benchmaster or also Sidebench?
I think, I don't know. I think Benchmaster will do it for you as well. All right, so if we go across, we'll start to see that we're starting to see some of these workloads being kind of reported. I can't actually see it myself, so I hope you guys can see it. But yeah, so and then there's some docs on the website, sidebench.io, and there's the kind of GitHub as well. It's open source, it's GPL, so you're welcome to use it and contribute. So let me go back. There's one more slide. Where is it? It's gone. Okay. Let me find it. Oh, is it over here somewhere? No? Oh, here it is. Where's my cursor? This is why everyone else used the clicker thing. I had to be clever. Okay. So the final thing is ideas for the future. So what we thought would be cool is like a workload generator. So you could basically have this daemon. This is like a dream idea, pipe dream idea. But as you can tell, we've made this particularly for our own use cases. So it's very much what we needed. So it might not be what you need, and that's fine. But if it is, then that's great as well. So one of the things that we'd quite like to do is have a workload generator where you could kind of sit and watch how a Ceph cluster behaves over time, and then spit out a set of Sibench benchmarks that will give you a representative kind of, this is how you've used this cluster over the last month or whatever, and here's a bunch of benchmarks that you could run to help you optimize and get to a solution that's going to make sense. Another one is sweeping over OSD counts, which I actually wrote a script that did this, but I never merged it into Benchmaster. But basically the idea was that if you want to see how Ceph linearly scales, you can know out the OSDs, or sorry, not know out, but take out the OSDs up until the point where you only have 3 nodes, run the benchmark, and then add in an OSD node and run the benchmark again, add an OSD card. And we actually did this quite successfully for a while, and we could see the linear increase of performance. So that made everyone happy. Also, meta operations like snapshots or OMAPs, or being able to like create and delete images, or some other things in Ceph which isn't necessarily just reads or writes, would be cool to add. Kubernetes support. So we have a lot of customers using our Ceph as kind of CSI, persistent volumes, and having something that's friendly for that would be interesting. And yeah, I'm interested in hearing your guys' kind of questions, thoughts, feedback, or whatever you think might be cool as well. And yeah, that's it. That's basically it.
Danny, great talk. Thank you. Actually, on that last slide, one of the things that I think would be interesting for me or for us would be the ability to profile a future event, like what would happen if my load went up 50%, what would happen if I added 50 OSDs, what would happen if I decreased by 50 OSDs, like benchmark against that and see what your performance would be, because there's tuning considerations for those events to plan ahead.
Yeah, no, that's another good idea.
Hey, Danny.
Hey.
I'm Mark.
Yeah.
So I'm super impressed that you did a live presentation. Good job. So I definitely want to talk to you later about all of this. But first question for you is, if I wanted to just use the individual pieces that you have for like doing block or doing S3 testing, do you need the daemon to do that, or can you just run it like individually on a client like you'd run FIO?
You need, so the fundamental architecture of Sibench is you need to have the way it works is the daemon listens on a port, and then Sibench itself is both a daemon and a CLI tool, so you can run it from any of the daemons or just run Sibench. But you start the server on wherever you're benchmarking from, and that listens, and then you talk to that server over the Sibench port and say, send this job out, send that job out, and then as you add more servers, then you just add them to the list of things that you're using.
Okay, so you can't like just run it in like a client-only mode where that client is doing like a contacting like an RGW server or like talking via librd.
You cannot today, I don't think, as in if you downloaded it today, but I imagine that would be a fairly trivial thing to add. You know, that's just a command line modification to get that to work.
Like I'm thinking it'd be really interesting to look at this as a validation for like FIO, right? You want to see whether or not both tools agree with each other. So yeah. Well, cool. Yeah, I'll let other people talk.
No worries.
We should talk later.
Yeah.
It looks fantastic. The kind of having used Cosbench and seeing this is like night and day. That just looks absolutely fantastic. And I like the FIO style output. I'm just curious about like some of the findings. You've got like 1 million candle power flashlight now to look at performance with the Sibench. What were some of the things that surprised you for different customer deployments?
So I didn't do most of the benchmarking. I've done quite a bit of benchmarking with Sibench and with Benchmaster. But that was a couple of years ago, or maybe a year and a half ago. But we've had a whole bunch of different teams within SoftIron doing benchmarking across different things, and particularly when we got to faster tiers of storage, the optimization of the underlying Sibench driver mechanism, there was a bit of a refactor there to make sure that it was on par with what FIO was doing. So yeah, if the question is now that you have a benchmarking tool, how does Ceph compare to other things? It's hard to say because we've only benchmarked Ceph with this, not.
I meant just like within Ceph, like more, you guys are using that ARM architecture.
Yep.
Increasing the core count or
Yep.
increasing RAM. Did you guys find anything sort of interesting? Like maybe you had too many cores or more than you needed or not enough?
Yeah, we did. Yeah, for all of the above, depending on which tier of storage, right? So for when you go from hard disk to an NVMe, and that's super important for us to know what's the next appliance we want to build and what's the right hardware architecture. So our platform team has been using this day in, day out for a couple of years now to try and to help them understand how to architect the next generation of appliances and what would make sense and what wouldn't.
How many resources the clients need to run the tests? So CPU, RAM.
I've run Sibench from like a 4-core ARM machine, so it's very lightweight. And you can specify the factor of threads it uses. So by default, it'll use 1 thread per CPU core, but you could do 0.5. You could only have 1 thread. It's pretty lightweight, but obviously your results aren't going to be great. Are you thinking to run it in containers or run it en masse or something?
I'm just thinking about if I really have a large cluster and I really want to saturate the network and I really want to figure out what is really the next bottleneck I will hit. So
Yeah.
I have to take into account from my experience when I did this benchmarking test. I have to also to think about what could be the bottleneck of the client.
Sibench, yes, yeah, absolutely, and that's exactly the process that we've gone through. Of like, okay, we have this, 42U, 42 OSDs, the NVMe, and this cross connect, and where is the bottleneck, and doing it over and over again, and then surprising ourselves like, oh, you didn't think about this or whatever. Right, so
yeah, for example, entropy. If you generate with entropy your objects to test and so on, that's also sometimes a bottleneck. And even delays the execution of your program as well. I mean, I really did this on Ceph clusters with I think next to 3,000 OSDs.
Wow.
So and with really 20, 50 clients to really saturate the clusters, and it was not possible. So
yeah.
Okay, thank you.
Yeah, we found that it was scary how many drivers we would need to properly drive a large OSD cluster. We almost needed as many drivers as we needed OSD nodes, and so you'd end up with like 2 or 3 racks, and then half of it is drivers and half of it is OSD nodes. So yeah, you need a lot of horsepower.
Yeah, so related to that, so does it support essentially launching a fleet of Sibench running on different servers and being able to kind of coordinate that?
Yeah, that's the whole point. The whole point is, I mean, I ran it in a very kind of caveman way, but the whole point is to have loads of drivers, and that's the kind of why it's a daemon rather than a command line tool. Is that you install a daemon on, like, let's say 100 servers, and then you provide those 100 servers to Sibench, the command line tool. And the command line tool is not doing anything. It sends the jobs off to these workers and then picks them all back up again.
So it's just aggregating them back into
Yep.
it's just summarizing.
Yep.
Okay, got it.
There's a question over there.
Will the tool be available across distributions?
I think on our so we've the Benchmaster is Python, and we have just like a pip install type of thing going on with Sibench. It doesn't actually have many dependencies, and I think we've packaged it for Fedora and Debian at the moment. So if you go on sibench.io, there's some instructions for a few different distributions where it's packaged, but it's not in upstream package repositories yet because who has time for that? Yeah.
One last one, Danny.
Sure.
You mentioned obviously Ceph has background tasks that are running. How does Sibench sort of factor itself out of that and also report on those background tasks as being an impacting factor?
It doesn't, and so it's something you really have to be aware of, which is why we removed the delete thing, because it was like we don't want to worry about it. We want to try and remove as many background tasks as possible. There's actually, if you look at the website, there's a best practices page of how to run Sibench, which I think part of it does tell you, like, please don't, here's some things you need to be aware of before running the benchmark to avoid kicking off background tasks in Ceph. But then sometimes you want those background tasks depending on what you're doing. So trying to just forget about it is never going to be an approach that's going to work. You want to think about, okay, am I going to end up with a bunch of deletes? And that's probably what's going to happen in real life, right? So it's trying to get something representative.
The A/B testing is important.
Yeah, 100%. Cool. Okay, well, thank you very much.